Hello everyone. So, and as we're discussing Module 8, CCNA 3, VPN and IPsec concepts, basically we'll go through defining what VPN is, and the type of technologies that are used to create VPN, the type of VPN that we have, depending on the infrastructure that we are using. We'll discuss as well key algorithms that are used in ensuring the private in virtual private networking. The private meaning data radio has to be confidential. It needs to be, there is need the integrity, then there is need the authentication for us to get access to that information. So basically, we'll pass through all of that. This is more to do with concepts. Couldn't deep into that much, just understanding the basic concepts. I think kana takudhipisa if you want to go towards network security, I think that's where probably the stuff to do with my configurations of VPN, how do you set up VPN, will be discussed. Now to get into this one, right? So module objectives, uh, basically is to explain how VPNs and IPsec are used to secure site-to-site in remote access connectivity. Describe benefits of VPN technology, different types of VPN, then explain how IPsec framework is used to secure network traffic. Definitions. What's a VPN? A visual VPN is used to create an end-to-end private network connection. Basically, let me try to simplify this early. VPN is creating a private network over a public network. When we're talking of a private network, we are talking of, I think, security, securing our information, making our information confidential. But how are we making it confidential? We're making use of the public network to transmit information and at the same time keeping it private. So can I start as a public, can I start as a public network? It's mostly to do with the internet. So if this is our internet, this is public. Everyone has access to this. So there is no confidentiality, there is nothing. Everyone has access to that. This is company A, this is company B. Company A and company B, zero communicate privately. But how do they do it? Kana between them and a public network. Actually, there are two ways of communication connect. They can create infrastructure and connect these two directly, which will be private. But unfortunately, creating a separate infrastructure like that one will be very costly. Zodura, that's more of a dedicated line ring connected directly company A and B. So you have to have the infrastructure which can connect to my companies wire, which is very expensive because getting equipment, budget maintenance of that link, etc., etc. Another way of doing it is making use of the public network E, which is already existing. The infrastructure is there. I see you, but it's there. We can make use of that. Try to make use of this communication via the public network. Information yangu won't be safe. Ikawani kunoko, it is safe because this is dedicated to communication between company A and B. Ikawa via the public, I see safe. So we have to create a tunnel. That's the technical term. We create a tunnel between a company A and B via the internet. Internet iripo, anakuva. But there is now a tunnel uh, between these two devices. Yeah, no tunnel already. So even if our tunnel is within the public network infrastructure, it only now provides communication for access between the devices A and B. Therefore, that's how it's private. This is technical. Technical, but basically what is happening about any encryption, number one, traffic is being encrypted so that even if you can put an app up via the public won't be able to get access to that information. So basically, that's what a VPN is. A VPN kutora information more encryptor, more some hashing algorithms, more some authentication, more whatever you can to keep it confidential. Then more send via the public network infrastructure. So you are making use of that infrastructure basically to transmit your information in. And that is basically what defines a VPN. Technical terms, technical definitions. Let me see. A VPN is virtual in that it carries information within a private network. We've gone through this. It's virtual. Virtual meaning physically it's not there, but it is there. There is a connection, physically not there, but it's there. We're using the infrastructure, a public network, to ensure connectivity between our networks, in this case, company A and B. Then probably a VPN is private and that the traffic is encrypted to keep the data confidential. Then there's an element of privacy. Is ndo panopinda algorithms, encryption, hashing, authentication, etc., etc. Then we have devices that are used. I think you can see from the diagram. We have devices that are used to establish, as well as managing these connections. So probably a router, one of the devices that is used, especially on side-to-side VPNs. We have two routers on each end. Then pamarauta ipapo ndo panoiswa maconfigurations yekuti traffic ichafamba between link iri, traffic ichafamba iri inenge iri encrypted. So pane maconfigs anoiswa at this end, pane maconfig anoiswa at this end on those specific interfaces. Then traffic yese inenge yakupfuura apa inenge encrypted because of what is being configured here. So you have these devices that can be configured to do that. We have the firewalls that can be configured to do that. Small office, home office routers, they can be configured as well to do that. Then we have even our personal devices, my desktops, my laptops, even phones. I think ndo panopinda up. They can be configured as well to access information via VPNs. So these are some of my tools, technologies, if you can say, that we use to set up establishment and management my VPNs. My benefits. Benefits of VPN, I think cost, I've discussed that one. Organizations can use VPNs to reduce their connectivity costs whilst simultaneously increasing remote connection bandwidth. Right? Cost saving in the sense that you are making use of infrastructure iripo kudhara. Hausi kutsvaga infrastructure yekuti uise internet yako. No, internet itoriko kudhara. You are just making use of that infrastructure. Oshandisa algorithms to encrypt information yako yoenda. So it's cost saving in the sense yekuti kana uroda kuwane private connection, then uchada kuva nema-devices, the whole infrastructure yekuti ukwanise kuita that communication. Also in terms of bandwidth, I think internet it has a lot of bandwidth. Iwewo kana uda kuita wega, it goes back to infrastructure as well. You need the infrastructure to support that bandwidth dedicated, which is a bit expensive. So cost saving, I think, is a clear benefit. Then in terms of security, obviously, we see my VPNs, they use IPsec, for example, IPsec, IP security, a technology which basically encrypts and authenticates information ESA between two endpoints. So in terms of security, it's a plus. I think that's why we have my VPNs, private, virtual private. The private in VPN is security, scalability, ability of a network to grow. It's very easy to scale kana uchishandisa VPNs. Why? Going back to infrastructure. internet, the devices are already there. If you have a dedicated link, kana wakuda kuita scale, it means probably you need another link. That's more infrastructure. Zvodzoka futi cost. So it's a bit difficult to add new networks. Ndikaita company A, B, C. Ndikaisa dedicated infrastructure for this. Ndoda futi dedicated infrastructure for this. This is not easily scalable, this one. But kana ndichishandisa internet A, B, C, I can easily scale because the infrastructure is already there to make my connections that are required for VPN. So in terms of scaling, it's a bit difficult to scale Kanatisana VPN if we have my dedicated links, more infrastructure. Uh, Compatibility, this one is to do with the VPN being able to work across quite a number of technologies. VPNs, ne fiber, it works. Ne DSL, it works. Ne cable, it works. Wireless, it works. So in terms of compatibility, VPN is not an issue. It is compatible with quite a number of broadband technologies. Then to end up types types of VPNs. So primarily, VPNs, they're deployed in two ways. We have site-to-site. This one, then we have remote access VPNs. When we talk of site-to-site VPNs, this is the type which is established when two entire networks are connected. Two entire networks are connected. So if I have network A and I have network B and they are connected, that is a site-to-site. That is a type of a site-to-site VPN. On the contrary, the other one, and the remote access, this one is usually a case where a remote user gets access to resources via VPN. So here we have a user getting access to the network. There is a difference there. Networks, networks, remote user, networks. I think let's go through, probably we'll highlight a few differences between site-to-site and remote access VPNs. Right. My site-to-site VPNs, they make use of what we call gateway-to-gateway connections, where we have routers or firewalls on one end, on each end. So kuno ndinoita router, kuno kundoita router. So they make use of gateway-to-gateway. So there's a gateway here, there's a gateway here. So that's gateway-to-gateway communication. One characteristics yema site-to-site VPNs. Another characteristic ndeyekuti my users muno they don't have the knowledge yekuti pane VPN iri kushanda. My users they just send information yayo. Chinozoziva kuti there is a VPN iripo, these two devices ndozvinozoziva dzakuendesa via this link or vice versa. So that's another characteristic ye-site-to-site VPN. On the contrary, ukatarisa kuno user uyu has knowledge yekuti they are using VPN because it's usually they're accessing it via the web or there's a software VPN it already installed on this user so that they can be able to access my resources via VPN. So site-to-site remote access, I think main difference, if I'm connecting two networks, then probably the type of VPN that I'll use is site-to-site. If I'm connecting just a user or users to get access to resources, probably I'll need a remote access type of VPN because it's now not a network but a user or a number of users at different sites as well. So I think that's the main difference between site to site. In this example, you can see this is an example site to site because we have a gateway here, we have a gateway here. Tiny already create kwap. Our kurawa, no knowledge. Our tombo zodi kune VPN iri kwere. no knowledge of existing setup to provide VPN services, site-to-site remote access. Then, like I was saying, this is remote access where a client, a user, initiates a VPN connection. That can be either via the web or via an application. Examples, I think, in Indonesian is what's the name? Is it Tubo? I think I have an application as a Tubo or something. Yeah, Tubo VPN. That's a software. It means I'm a client making use of VPN. So that's a type of a remote access VPN because I have an application, a proper phone pump. I'm not a network, I'm just a client. Right, let's move to enterprise and service provider VPNs. Right, when we talk about VPNs, we have classifications that now, depending on who owns and who manages the VPN. So when we have enterprise VPNs, that is a case where common solution for securing enterprise traffic across the internet, site to site, created, managed by the enterprise. So with enterprise VPN, this is an example where the organization, the whole VPN is managed and owned by an organization. The type we have Ndo site to site. That's an example here. Your enterprise where two networks are being connected using VPN gateways, or everything being managed by an organization. Difference to the one service provider. Service provider, they are going to provide the VPN services. Example, the MPLS, layer 2 and layer 3 MPLS VPN. So I think this one is very much straightforward. A classification depending on who owns the VPN, who owns the infrastructure that's providing the VPN. Enterprise VPNs, ndiso varidzi vemarouters, ndiso tiri configurations, ndiso varidzi VPN yacho. With the service provider VPNs, it's the service provider who is responsible for that. So we have MPLS. I think we'll discuss those two Pamberi, layer 2 and layer 3 MPLS provided by the service provider. Classifications. Tenda Mama types of VPNs, remote access VPNs, we've discussed those. Client connecting to a network. Remote access VPNs let remote and mobile users securely connect to the enterprise, typically enabled dynamically by the user when required. We have clientless VPN, we have client-based VPN connections. Right, the type of remote access VPNs we have clientless and client-based. When we talk of clientless, that's where we are using the browser, the web. You go to the web browser, or it's a website which will help you connect to a remote network via a VPN. With a client-based, we have a software it installed on your device as a client. That's the software that you use to initiate a VPN connection. Difference between clientless and a client-based VPN. So I think here we're using a browser. Here we're using a software. That's the basic difference. So in the case here, we're in a Turbo VPN. That basically means I'm using a client-based VPN connection. I don't have much knowledge in my websites which uses which I use to initiate my VPN connections, but I can bet a simple Google search will get us there. So these are the types of remote access VPNs that we have. Then to end up SSL VPNs. Right, when we talk of SSL or TLS, transport layer security, it used to be called TLS. Okay, when we talk of SSL, They're saying it uses public key infrastructure, digital certificates to authenticate peers. VPN implemented is based on access of requirements. Table compares IPsec and SSL. IPsec applications, strength, encryption, complexity. Right. So those two, IPsec and SSL, are basically encryption protocols that are used for securing traffic via VPN. You can either use SSL or IPsec, but at times it's also good to use both of them. They have stark differences between them. So, for example, if we take a look at anything to do with my layers, if we take a look at IPsec, in terms of the OSI, for example, this one operates at layer number 3. This one operates at layer number, let's just say the application layer, 5, 6, 7, I think. So this is the network layer. Right. So if you wanted to make encryption yako based on IP traffic, then IPsec is the one to use. And if you establish VPN yako based on IP traffic, therefore it means traffic yes is going to be encrypted basically. So for example, let's say I have let's put point A and point B in the VPN tunnel yedi. Ndika encrypta via layer 3. It basically means ndine gateway somewhere panapo. Then traffic yes erupinda is going to be encrypted because ndiko encrypt at layer number 3. On the contrary, ndika encrypta using SSL. Traffic yangu iri encrypt at layer 5, 6, 7. It means I can have a select of applications and not encrypt. So for example, between A and B, I can choose to say, don't go encrypt a web traffic chat. So SSL, it allows you to separate different types of traffic. IP, igumba more a kind of a thing. Everything in IP gets encrypted, including all the traffic EM application yacho. Then if we are using the SSL to encrypt, then pick different types of traffic, web traffic, traffic management, SSH, HTTP, that's web traffic. Any other type of traffic in the application layer, email traffic, traffic file transfer. I can pick, this is the type of traffic that I want to encrypt basically. So that's the difference between IPsec and SSL. Some advantages, some disadvantages. At times, like I said, it makes sense to use both my protocols. Encrypt at layer 3 as well as encrypt it at the upper layers in the application layer. Then in terms of authentication, you can see IPsec in a two-way authentication, meaning is authentication at both ends. Why at both ends? It's usually a case yekuti pane router. Then we have IPsec being used to create a tunnel between these two routers. Authentication happens at this gateway. Authentication happens at the other gateway. Meaning in a stronger authentication, if you want to get access, it's not difficult, but it's more difficult to get access, let's say to attack. Kana tini chianza IPsec because we have two-way authentication, but the other one on the other end in a one way. Then encryption, my encryption algorithms, IPsec, they're a bit stronger than SSL. I think we'll discuss my different types of algorithms that IPsec. IPsec supports a wider range of my algorithms, are much stronger as well. Then in a connection option, only specify specific devices with specific configurations can connect any device with a web browser. All right, for this one, only specific devices. My device is able to be specific and why your routers, your firewalls, those are the type of devices that can be used to create my VPNs. But On the other hand, with SSL, a computer, basic computer, can initiate a connection to a remote network just using a web browser. So it's quite simple. If we can summarize, IPsec sounds a little bit more complex, even setting up yacho to kudama routers, to kudama firewalls and all. But SSL on the other end, me and my computer and the software or a web browser, I can be able to get access to VPN services. So I think we can conclude IPsec is more suited for the site-to-site type of VPN. This one, whilst SSL is more suited for remote access. So can Android remote access? I use SSL. Can Android site-to-site VPN? I use IPsec. Site-to-site IPsec VPNs. I think we've gone through this. Gateways on each end, my configurations on these gateways. Do not decide or the turn already reach a BFSA. End host send and receive normal unencrypted TCP IP traffic through VPN gateway. End host, they have no knowledge. I think it's the same thing. No knowledge of what is happening. So kunok, traffic inoshika kunok is not encrypted. Traffic inovap is not encrypted. The moment inoshika panap, ndo panotanga kuti encryption, then traffic yese yakunda mutana inenge private traffic, if I can say. The VPN gateway encapsulates and encrypts outbound traffic from a site and sends the traffic through the VPN tunnel. Receiving gateway strips the headers, decrypts, relays packets towards. Okay, I think we've been saying this all along. Encryption, encapsulation, encryption. So you can see when you're talking encapsulation, traffic is up. Basically, what's happening, traffic is in let's say at layer 3 IP. Take a header, take another header, the IPsec ratio. Then to add another header, probably re-authentication, provided dominant authentication and encryption, we can add re-integrity. Then to add another header, extra layer of security. If you can take a look at this, network tunnels actually. I think I've seen an image somewhere. Those network tunnels actually encapsulation, I think a true beta. Adding extra information. Information here they are true not encrypted ish. Got IP. Then we add extra information, encryption, integrity, authentication, all the algorithms, the hashing, we add to that. Traffic panels open up. For you to intercept traffic here, you have to remove just those security hash. You have to remove remove a pap and decryption, with hashing, reverse hashing, so that you get access to that information, which is very difficult depending on the algorithms that need to shanties, etc., etc. So site-to-site VPNs, there we have it. Then we have GRE of IPsec. Right, with the GRE of IPsec, it's a case of let's start with IPsec. IPsec as a technology, it only supports unicast traffic. So if I create a tunnel rango site-to-site yango, I'm using IPsec. The type of traffic that I can support in a unicast, point to point kind of a thing, from one point to another point, that's it. Right, kubva kusvika apa, that's it, unicast. From this gateway to another gateway. Ndo IPsec as a technology. But problem iripo ndeyekuti we have other types of traffic which require a multicast and broadcast kuti zvifambe. For example, my network layer protocols, my routing protocols, let's talk my routing protocols, OSPF. Pane a little bit of multicasting in network up, sending my messages to a number of routers. So if we want to use VPN, at the same time use those protocols, it becomes very difficult because IPsec does not accommodate multicast and broadcast traffic. So how do we deal with that? We introduce this GRE, generic routing encapsulation. So GRE is a technology protocol that supports multicast traffic. However, I see secure. So it supports multicast traffic, it's really secure. So you can see the combination here, GRE and IPsec can basically allow us to support multicast traffic at the same time you have security. So basically what you see happening is encapsulation yedu data red iro robva raencapsulated kwane layer 3 header redu paip apo traffic iyoyoyo inogona iri multicast at times then isusu tobva tareencapsulata negre. GRE, it allows us kuti tizokwanisa kuisa IPsec on top of it so that traffic yedu kana inge iri broadcast panapa tinokwanisa kuifambisa via the tunnel. So if I repeat, IPsec iri ega apa iunicast, meaning IPsec iri apa ichi iunicast ichi. However, traffic yedu imulticast. So tunoisa GRE apo so that it accommodates traffic yedu kana iri multicast panapa. Panozotanga kuvhurwa maheaders aya pa-de-encapsulation ndo patinozoona an element yemulticast yacho with GRE helping us with that. But traffic yedu painenge iri kusendwa inenge irikuita kunge unicast. But tikazotanga kuvhura tikaona GRE, that's where we get to realize what traffic yedu multicast. Then tosend to different devices dzatinenge tinadzo. So GRE over IPsec is basically a sort of a workaround yekuti tiaccommodate ma-protocols anoshandisa broadcast and multicast traffic since IPsec yedu isinga accommodate ichiaccommodate only unicast type of communication. Right, specific terms to define apa GRE with the passenger protocol, which is the original packet encapsulated by GRE. So iri ndo passenger protocol ready, the original packet ready. Then we have the carrier protocol, which is GRE, which encapsulates the original packet. I think we can see from the diagram there. Then we have the transport protocol, which will be used to transport information yes in a GRE plus the original data. GRE over IPsec. Right. This diagram, I think, shows perfectly when you talk of encapsulation, when you talk of materials, when I did this, I was thinking there are tunnels, but I was thinking actual tunnels. Because there's an actual tunnel which is being created. In reality, tunnels are it's more of encapsulation. You didn't get critic. So you can see you have original data rago being encapsulated in a GR tunnel, but the encapsulation ye IPsec. Do pan encryption zero pana. From the outside looking in, what you see is one huge tunnel or IPsec, unique type of traffic yedu. But paranoshikono vhurwa panapa, tichivhura GRE ishi, ndo patinoona an element yemulticast yedu yeyo. Kuti this is actually not unique type of traffic. GRE comes in multicast. Ikuenda copy. Then totanga create futhi ma-tunnels anoenda to different devices depending on my destination networks edu atinenge tinawo for our multicast. Example, Branch HQ needs to exchange OSPF routing protocol over an IPsec. GRE over IPsec is used to support the routing protocol traffic over the IPsec VPN. Specifically, OSPF packets, those are the passenger protocol, encapsulated by GRE, encapsulated by in an IPsec VPN tunnel. then irochisendwa, our information is secure. So in summary, to understand the issue GRE of IPsec, IPsec supports unicast traffic. We have other types of traffic, the three unicast, multicast, broadcast. How do we support those? Tikuda kushandisa IPsec, yes, but tinoti tikwanise kusapota multicast. Tinoshandisa protocol GRE, which allows us to have multicast traffic. Then GRE iroro tozoriisa IPsec tunnel redu. Then problem solved basically. DM VPNs, time, 2 minutes. I think I can end this one. When we're talking of my dynamic multi-point VPNs, here we are trying to simplify the VPN tunnel configs, provide flexible option to connect to a central site with branch size. Right, DM VPN, it's a technology which allows us to have multiple remote sites, achishandisa ma-VPNs, but without needing my permanent static tunnels between every pair. So I can put it in this way. All right. I played around with the, I think that's one. So let's say, for example, I have ndine masite angu ndine router A, router 3 masite to site like this. Right. Under normal circumstances, uh, by the way, if this session ends midway, I can see 1 minute. I think you can join using same link to one more session. Right. If I have 3 sites like this, it means I have to create a tunnel pan up. I have to create a tunnel pan up. I have to create a tunnel pan up. That's a problem in terms of my configurations and in terms of the amount of bandwidth that I'm using. That's a problem in terms of if I want to scale as well, that's an issue. Solution yedu ndo ima dynamic multi-point VPNs. It allows us to have a central point instead of having my static 1, 2, 3. We have a central point area which acts as the hub. Then we have my which acts as my spoke.